Hello, this is an introduction to static electricity, some of the initial concepts around static electricity. Now, you're very familiar with the idea of static electricity, and if you think about it, you can probably come up with a couple of examples of things in your day-to-day world that involve static electricity. You might think about, why do socks sometimes stick together when they come out of the dryer? Why can you rub a balloon on your hair and then stick it to the wall and it sticks there? That sort of thing. And so these are ideas about static electricity. If you have a roll of Scotch tape with, it's not the perfectly clear one, but the transparent kind of cloudy one, if you've got one, go grab it. And then if you take it and rip a piece off really fast, and then tear it off and dangle it, it will probably go zoop and be attracted to your hand. Give it a try if you've got the tape. So something is going on there. There's an attraction with this tape. And so this is all about static electricity. If you take another piece of tape and rip it off, bring the two together and see what they do to each other. Do they repel each other? Do they, push each other away? Do they attract to each other? Does the second one also get attracted to your hand? Explore a little bit if you can. So with static electricity, one of the things I like to ask is, how many types of charge are there? So how many types of charge do we have in our world? So think about that. What types of charge, what are the names of the types of charges that you have learned about in your past schooling? Most of you are probably going to come up with positive. So we can have positive charges. We can have negative charges. Is there anything else? Can you come up with any other type of charge? Maybe? Some of you probably thought of neutral. And so we've got this idea of positive, negatives, neutral. Are they all three types of charge? Well, I'm going to go back again, probably back to like middle school, junior high science. If we have a positive charge and a positive charge, we have two positive charges, what are they going to do to each other? If we bring them close, how do they interact with each other? You probably say, well, they repel. If you remember, they are going to repel each other because like charges, similar charges, repel. So like charges repel. If we had a positive and a negative, what are they going to do to each other? And they attract because opposites attract. Okay, so we've got those two. Opposites attract and likes repel. What about this idea of neutral? Is this a third type of charge? Well, if you were to take something positive and something neutral, you would find, and this is like the tape, there is an attraction. So a positive and a neutral do attract. So we've got kind of the opposites attract going. What happens if we take a neutral object and a neutral object? Okay, you can do this. These pieces of paper are neutral. They're not charged at all. And when I bring them close to each other, what happens? Do they attract? Do they repel? I'm not seeing anything because there's nothing. So what happens with a neutral and a neutral? Nothing's happening. We do not have like charges repel. And so neutral isn't a separate type of charge. We only have two charges. We have two charges. We have positive and we have negative. So what does neutral mean? So what do you think neutral might mean if we only have two positives, two types of charge? Well, I'm guessing your first thought is, okay, it has no charge whatsoever. It isn't positive, it isn't negative. And that's one possibility. There's another possibility. Can you come up with that one? The other option is that it's balanced out. It has equal numbers of positives and negatives. So in our day-to-day world, if we have a neutral object, like a piece of paper, does it have no charge, or does it have equal numbers of positives and negatives? Well, what are charges? Let's think about what really are the charges. What is a positive charge? What is a negative charge? And to do that, let's think about what what stuff is. What is this cloth made of? Okay, it's made of, I don't know, it's microfiber. I don't even know what that is. Let's say it's cotton. Let's say I have a cotton cloth. So this is made up of the molecules that make up cotton, and the molecules are made up of atoms. What are atoms made up of? There's 3 parts to an atom. You remember what's an atom? In the middle of the atom, in the core, we've got protons and neutrons, and then we've got the electron cloud all around it. So protons, neutrons, and electrons. All matter is made up of stuff. Well, okay, that sounds funny. All matter is stuff. Yes, right, that's because it's stuff, it's matter. All matter is made up of positives, of protons, neutrons, electrons. So all matter has charges in it, which means that when we're dealing with things, with matter, with stuff, we're going to be talking about a neutral object as one with equal numbers of positives and negatives. Can we have neutral be something with no charge whatsoever? Well, what would be a situation where there is something with no charge whatsoever? The only place we're going to encounter that is a place where there's no matter. There is nothing there. So a complete vacuum or space. Yeah. So if we were out in space and had a little cube of space, a little cube of space or a vacuum, there's no matter in there. There are no atoms, no protons, no neutrons, no electrons. And so that would be no charge whatsoever. But pretty much for everything we're dealing with, because we deal with stuff, neutral means equal numbers of positives and negatives. And so that's just the initial steps of how many types of charge there are, and that's the first thing we need to think about when we're learning about static electricity. So there is step 1. Good job for watching.